Hello, today or this video will start a chapter about sinusoidal steady-state analysis. So here we mainly have AC source for the circuit, and we need to calculate the current and voltage. Similar to the chapters in circuit theory, which has nodal analysis and mesh analysis, and Kirchhoff law, Kirchhoff current, and Kirchhoff voltage law, and Ohm's law. But the only difference here is that we have AC instead of DC. So usually what we are doing here is that we convert the circuit to phasor, convert the source to phasor, and then convert the capacitor and the inductor also to phasor, and then solve the circuit using nodal analysis and mesh analysis. So as I mentioned here, the steady state response for the circuit to sine inputs, sine of course sinusoidal input could be sine or cosine, can be obtained by using phasors. So this is the easiest method to find the current and voltage in the circuit. This is what we call circuit analysis, how to find voltage and current. Okay, so instead of solving differential equation, you can use phasors to solve the circuit. We can use Ohm's law and Kirchhoff current law and Kirchhoff voltage law, and also we can use nodal and mesh analysis, beside of course some other methods like Thevenin and Norton and superposition. So all these theorems are applied on the circuit that has AC the same like DC. The steps here is that we transform the circuit to phasor, okay, or frequency domain, and then solve the problem using circuit techniques like nodal analysis, mesh analysis, superposition, etc. And then after that, at the end, we transfer the results back to time domain. If you want, of course. Sometimes we don't need that, but if we want to convert it to time domain, yes, you can do that. Let us take this example here. We have this circuit. So we need to calculate as Ix, this Ix. So how do you calculate Ix? One way to do that is to use nodal analysis, of course. So we will convert the circuit. As a first step is to convert the circuit to phasor. Here's the source. We have this source is 20 cosine 40. So actually the amplitude is 20 and the phase is 0. So it is 20 and 0. So this number one source. We don't have another source. 10 is the same. 1 Henry is supposed to be J omega L. J omega L. In this case, it will be J4. How it is J4? Because omega equal 4 here. So J omega L, J4, L is 1. So 4 times 1 is 4. And this one will be 1 over J omega C. So 1 over J. Okay, omega is 4 times 0.1, which is C, 0.1. So actually, this one is negative J 2.5, because 1 over 0.4 will be 2.5, and 1 over J is negative J. So this is just negative J 2.5. And see, it is an ohm here. For this inductor here, it is J omega L. So it is J 4 times 0.5 will be J2. So now the circuit is ready to apply either nodal analysis or mesh analysis or any method you like. So let us apply nodal analysis, for example, here at these two nodes, this V1 and this V2. As we know before from circuit analysis 1 or circuit 1. So the first current, this current here, equal what? This current is V1 minus the voltage. V1 minus the voltage divided by 10 ohm. Okay, so this one here, V1 minus 20 divided by 10. So this is the first current. So let me use the pointer here. So the first current from V1 to the source is V1 minus the voltage, which is 20 divided by 10 ohm. Second current is V1 minus 0, which is the ground, divided by negative J 2.5. And the third one is V1 minus V2 divided by J4. There it is. So then this one is the first equation. Second equation is at V2, so it will be V2 minus V1 divided by 4J. There it is, for J4. And this one here is just negative 2Ix, is current from V2 to the ground. It is negative 2 times capital Ix. And the third one is V2 divided by, or V2 minus 0 divided by J2. There it is. So this is the second equation. Here we notice that we have dependent source, which is 2Ix. So we have to get rid of this Ix. So we look for Ix in the circuit. Here's Ix, this one here. So Ix is what? Is V1 divided by negative J2.5. So this Ix. Then we can substitute by Ix here. Then in this case, we'll have two equations in V1 and V2. We need to work on this to find the voltage V1 and the voltage V2. So after we substitute by Ix, this will be the equation here, the second equation. Okay, so we have these two equations now, this one and this one. So we try to solve them, to simplify them, the same way like when we solve any two equations into unknowns. For example, here we can just multiply by what? By the common factor here for 10, 2.5, and 4. Because J, you can move J up. This is not a problem. J, you can move it up. So negative J, you can move it to positive J as a numerator. J will be negative J as a numerator. So if you multiply by 20, 20 is divided by 4 and 2.5 and 10, then this will be the equation after you multiply by 20. 20 divided by 10 is 2. 2 times V1 is 2V1. And 2 times 20 is 40. And then negative J will be positive J. 20 divided by 2.5 is 8. So it will be J8V1. And then 20 divided by 4 is 5. And you have negative J here. So it will be 5V1 minus 5V2. You multiply by negative J. Both of them, you multiply them by negative J. Then you can simplify this equation more. So you have V1, you have 2 here, and you have J8, and you have negative J5. That will be J3. 2 plus J3 times V1 plus 5 J5 V2 equal 40. Move this negative 40 to the other side. For the other equation, it is the same. Also, you multiply by 20 and you multiply it, and you will get this equation here. And then you simplify it. You have, for example, V2, you have 5V2, you have 10V2, so it is 15. So it is 15V2. You have 16V1, you have negative 5V1, then it is 11V1. So 11V1 minus plus 15V2. Then in this case, you will have this equation here. These two equations, sorry, this one and this one, number 1 and 2. You can solve them. The easiest method here is Cramer rule. Then what you need to do is to convert this to matrices. So here's coefficients 2 plus J3 and J5, 2 plus J3 and J5. And the other one is 11 and 15, 11 and 15. So this is the first matrix. The second matrix is a vector that has the unknowns V1 and V2. And this equals the constants. Here you have 40, and here you have just 0. So 40 and 0. Okay. And then you solve these two equations into unknowns, and you can get V1 and V2. You can get V1 and V2. So how do we solve these two equations? So let us see here. So we need to find delta. Delta is the determinant of, this is not matrix, supposed to be determined. Okay, so it's supposed to be determined here. So it will be 2 plus J3 times 15, which is, of course, 2 times 5 is 30. 3 times, say 2 times 15 is 30. 3 times 15 is 45. So it will be 30 plus J45 minus J5 times 11 will be minus J55, which is 30 minus J10. And then you convert this to amplitude and phase. So it will be 31 plus 62 and angle negative 18.4. You do that, of course, because you need to divide. If you want to calculate V1, V1 is delta 1 divided by delta, and V2 is delta 2 divided by delta, according to Cramer's rule. So you need to convert everything to amplitude and phase, because if you want to do division, of course, you need to have amplitude and phase. Then delta 1 is the same here, the same like this one, but you replace the first column by the constants. So here we have, you see 40 and 0, replace this one by 40 and 0. For delta 2, you replace the second column, J, 5 and 15, by the constants, 40 and 0. And then you calculate delta 1 and delta 2 the same way. So delta 1 will be 40 times 15, which is 600, minus J5 times 0 will be 0, of course, so it will be 600. Delta 2 is 2 plus J3 times 0, which is 0, minus 40 times 11 will be negative 440. So this is delta 2. Okay, so now V1 is this 600 divided by this. Okay, this one divided by this one. So here you divide the amplitudes. So it will be 600 divided by 31.62. When I get a calculator, calculate it. So it will be 600 divided by 31.62. There it is. So it is 18.97. And of course, the phase, you subtract the phase. The phase is 0. We don't have phase. So 0 minus 18.4 will be plus 18.4. And for this one here is negative 440. So this is actually is 440 and the angle 180 degree. When you have a negative, you can cancel this negative and add 180 degree here. So you can say, okay, just 440 divided by 31.62. Okay, this will be 13.9. There it is. And the angle is what? Is 180 degree. Why is this 180 degree? Because it is negative. It is negative. Minus would be plus 18.4. So it will be 198.4. You can leave it like this, or you can say it is equivalent to the same angle minus 360. You can do that. You can say it is 198.4, or you can say it is 198.4 minus 360. For example, 300 degree is negative 60. It is the same. 300 degree is the same like negative 60. The same. Okay, so here we calculated V1, we calculated V2. So what is required here? We need to calculate Ix, I believe. This was what's required. We need to find this Ix. So Ix is what? Ix is V1 divided by J, I can't remember, this one is what? Negative J 2.5. V1 divided by negative J 2.5. This is Ix. Okay, so Ix is V1. V1 is here, 18.97, and the angle 18.4 divided by negative J 2.5. Okay, so what is this actually? It is 2.5 and amplitude, and the angle is 90. Okay, and if you add a negative negative in the bottom here in the denominator, you can add 180 degree. So you can say, okay, this one is negative. It is 180 degree plus or 90 because of J, plus 180 degree will be 90. Okay, so actually it will be 270, or it is negative 90. So here you can just calculate this. So V1 is 18.97 divided by 2.5. It will be 7.5, almost 9. And the angle here is what? In the top, V1 is 100. It is 18.4 minus. Okay, minus what? Minus J. J in the bottom is 90. Okay, so minus 90 equal. Okay, and you have negative, another negative. This negative here. Then negative means that you add 180 degree plus 180 degree. So this is the easiest way to do this. So again, V1 is the angle here is 18.4. 18.4 minus the bottom here J. J is 90, so minus 90. Okay, and then because if you have negative here, negative of this one, this means that you add 180 degree, so plus 180 degree equal 108.4. So this is the angle. Okay, so if this is Ix, this is Ix, then you can convert it back to ix of t to time domain by having this 7.59 cosine 4t. 4t, it is cosine here, see, this cosine 4t. So to be cosine 4t plus this angle. If it happens that this one, instead of cosine, it was sine, and you have only one source, you can leave it sine, but at the end, the answer here will be sine. So assume that this one, well, instead of cosine, you make it sine. So the answer here will be sine also. So you can do that. That's fine. Okay, so if this one is sine, this one will be sine. If this one is cosine, this one must be cosine. But if you have two sources, one is cosine and one is sine, so in this case, you have to convert one of them to either cosine or sine.